So we're going to talk today more about rational functions and their graphs. Okay, so part of your homework today is you're going to match functions to their graphs based on their transformations. If you find your vertical asymptotes, your horizontal asymptotes, decide if there's a reflection, you can pretty much match your graphs. So for this one, for 31, we're going to match these graphs to these equations. Well, this one tells me, to get my vertical asymptotes, I set my denominator equal to 0, add 4, x equals 4. So I'm going to have an asymptote at x equals 4, 2, 3, 4. Okay, my horizontal asymptote, my top degree is 0, my bottom degree is 1. Top degree is smaller than the bottom degree, so my horizontal asymptote is at y equals 0. Okay, and then if you got some x-intercepts and some y-intercepts, to get some x-intercepts, you set your numerator to 0, which doesn't make any sense. There's no variables, so there is no x-intercepts. My y-intercept, I find f of 0, which would be 1 over 0 minus 4, which is negative 1/4. So this has to pass through 0, negative 0.25. So I'm looking for a horizontal asymptote that's 4 units to the right. 1, 2, 3, 4, no, 1, 1, 2, no, 1, 2, 3, 4. Oh, there's 1. 1, 2, 3, 4, there's 1. Nope, so it's between these two. Okay, so now I'm going to check and see if it's got my y-intercept. The one that has the y-intercept, this one's crossing at almost negative 1. This one's at almost 0. This one's closer to negative 0.25. Plus, I know that it has to boomerang this way because the fraction is positive. There's not a negative out front like this one down here. When the fraction is positive, it's got to boomerang this way. When the fraction is negative, it's got to boomerang this way. So I know that 31 has to be D. For 32, I'm looking for a vertical asymptote, denominator equal to 0, minus 3, x equals negative 3. My horizontal asymptote is the top degree is 0, the bottom degree is 1. Top is smaller than bottom, so y equals 0. So I'm looking for an asymptote at negative 3. 1, 2, 3, there's 1. And 1, 2, 3, there's 1. I can do x-intercepts and all that stuff as well, but I noticed that this fraction is negative, so it can't be this one. This would be a positive fraction. To be negative, it's got to boomerang this way, so 32 has to be B. I mean, I could go ahead and get my y-intercept, which would be at negative 1/3, which is right there. And you can tell this one doesn't cross at negative 1/3. So it's got to be B. Okay, 33. This one is going to have a vertical asymptote at 1. A horizontal asymptote, top degree is 0. Bottom degree is 1. Top is smaller than bottom, so y equals 0. So I'm looking for a vertical asymptote at 1. And those are the only two, so it's between those two. I can get intercepts if I want, but I know that this one has to shift up 2 units. Okay, so it's going to have to move up 2. Wait a second. Yeah, it's going to have to move up 2. So my horizontal asymptote should be 2. Why am I getting 0 there? Oh, because it's going to shift up 2. Sorry. Okay, so it's going to shift up 2, which is going to put a horizontal asymptote up there at positive 2. Which, let's see, does this one have one at positive 2? No, I think that one almost crosses it. Maybe it's close, I don't know. Anyway, the fraction itself is positive, so I know it has to be this one because it has to boomerang positive, and this one would be a negative fraction. So 33 has to be A. Okay, so on 34, again, and you can do all this if you want, but you can just use your transformations. This is going to be 3 left and 1 up. So I need a vertical asymptote at 3 left and 1 up. Not that one. 3 left, 1 up. It's got to be F. Okay? Alright, so there's some tricks to match graphs. Oh, we got more. Sorry. Alright, so this one now is going to be a little bit tricky because this could be negative x plus 4, which if you factored out the negative 1, that'd be x minus 4. So I'm looking at 4 to the right, reflect over y, and 1 down. Okay, so if I look for an asymptote, 4 to the right, 1, 2, 3, 4. There's 1, 1, 2, no, 1, 2, no, no, 1, 2, 3, there's 1. Okay, so it's between these two because it's got the right vertical asymptote. It's going to shift down 1, which means down here. And the only one that follows it is this one. Now, why is it reflecting this way when the fraction is actually positive? Well, again, this is going to reflect over the y-axis. So it would be here, but it reflected over y. So this one jumped over this way, and this one jumped over that way. Okay, so it's got to be E. And for 36, okay, we're going to go 1 to the right, 3 up, and this is going to reflect over x, which again is going to make it boomerang this way instead of the other way. So I've got to go 1 to the right, yeah, here or here, and I've got to go 3 up, 1, 2, 3, yeah, 1, 2, 3, yeah, and I know that it has to boomerang this way because the fraction is negative, so 36 has to be C. Alright, the next part of your homework is they're basically going to ask you to analyze graphs. And these are some things that they might ask. I don't know what they'll ask on every one. I'm just going to go through everything so that you can kind of see it all. So, we're going to start with my vertical asymptotes. So I say denominator equals 0. If I solve this, I'm going to factor 2 times 3 is 6. Factors of 6 that make 1 are 2 and 3. So I'm going to rewrite that as 2x and 3x. C is negative, so only the bully will get the middle. So bully 3 is negative, 2 is positive. Everything else comes down. 2 by 2. GCF by 2x would leave x plus 1. GCF by negative 3 leaves x plus 1. GCF again by x plus 1 leaves 2x minus 3. That gives me x equals negative 1. And add 3, 2x equals 3, divide by 2, x equals 3 halves, which is 1.5. So I'm going to have a vertical asymptote at negative 1 and at 1.5. Okay, to get my horizontal asymptotes, I look at the degree. My top degree is 0. My bottom degree is 2. Top degree is smaller than bottom degree, so my horizontal asymptotes at y equals 0. Okay, I can get some x-intercepts by setting the numerator equal to 0, which is silly. There's no letter in it, so there's no x-intercepts. To get my y-intercepts, I find f of 0, which would be 2 over 2 times 0 squared minus 0 minus 3, which is negative 2/3. So it's going to cross the y-axis at negative 0.6, repeating, something about like that. Okay, my domain and range I'll get after I'm decreasing, symmetry, all of that stuff. My vertical asymptotes were at x equals negative 1 and x equals 1.5. My horizontal asymptote was at y equals 0. If there's a horizontal asymptote, there's no slant asymptote. So now we should, to get the picture, we should pick points and plug them in, but we cheat a little bit and we use the calculator. So we know that it does this. Let me get a different color here. It does this. It's asymptotic between the asymptotes. It comes up and does this parabola thing in the middle, and it comes down over here. Okay, so there's my graph. So now my domain is going to go from negative infinity to the asymptote, union, start at the asymptote, go to the other asymptote, union, start at that asymptote, and go to infinity. And my range is going to go from, see how if I'm reading bottom to top, it goes from negative infinity to, let's say, 0, stops, and then starts again at 0 and continues up to infinity. My function is decreasing. Now you gotta trace it with your finger here. I don't know how I'm going to do this. Okay, this is increasing as I draw it. This is increasing. And so those parts are increasing. I'll get a different color. That's going to show color purple. This is decreasing. And this is decreasing because it's coming down. So to get those intervals, okay, this ordered pair right here, my y-intercept was 0, negative 2/3. So at 0, it's going to start to decrease until it gets to this asymptote, which is 1.5, and then union from 1.5 to infinity. It's also decreasing. Okay, your increasing would be negative infinity to negative 1 and negative 1 to 0. Symmetry, if you changed all of your x's to negative x's, nothing would change. So it's going to have even symmetry. Okay, boundedness, it's unbounded. Unbounded. Local extrema, I probably have a local max at negative 2/3, but there's no local min, and we got everything else. Okay. Alright, so it says find the intercepts, asymptotes, end behavior asymptote, and graph the function together with its end behavior asymptote. Oh, I think we were supposed to do limits. At the asymptote and at the end. So we've got quite a few to do. Let's do the end ones first. The limit as x approaches negative infinity. As I trace the function this way, it's getting closer and closer to 0. So the function is going to 0. The limit as x approaches positive infinity, if I trace it over here, again the function is getting closer and closer to 0. Then I've got to do these asymptotes, okay? And I'm out of room. Alright, so I'm going to do my first vertical asymptote, which is x equals negative 1. So what I do is I take the limit as x approaches negative 1 from the left. So from the left, I am approaching negative 1. I'm approaching this line from the left. So as I approach this line from the left, the function is heading up towards positive infinity. So the function is going to infinity. Okay, as I take the limit as x approaches negative 1 from the right, and what that means is I'm approaching negative 1 from the right. So what I do is the closest part to the right, this little vertex here, if I trace this as I get closer and closer to negative 1, that function is heading to negative infinity. So we say the function is going to negative infinity. Now we got to do the other asymptote. Okay, so I'm going to take the limit as x approaches 1.5 from the left, if I approach, where did it go? Sorry. As I approach, I get a different highlighted color here. As I approach 1.5 from the left, that's this side. So I'm tracing this function, and it's heading down to negative infinity. Okay? So we say, hold on, my pen is being stupid here. So we say the limit as x approaches 1.5 from the left, the function is going to negative infinity. Come on. Alright, and then we have to approach the limit as x approaches 1.5 from the right. And I don't know what my pen is doing here, sorry. So if I trace that, if I go from 1.5 to the right, I'm tracing it this way, and my function is going up towards positive infinity. Come on. So I say the function is approaching infinity. As soon as my pen catches up, golly, I don't know what's going on with this thing. Hold on. Sorry. Okay. Alright, so one more time. As x approaches negative 1 from the left, my function is heading towards positive infinity. As x approaches 1 from the right, my function, I'm on this side now, is going down to negative infinity. Okay, the limit as x approaches, I'm so sorry, I do not know why this is doing it. The limit as x approaches negative 1 from the right, I'm tracing this, and it's going to negative infinity. Then the limit as x approaches 1.5 from the left, that's tracing right here. That's going to negative infinity. And as I approach 1.5 from the right, that's going up to positive infinity. Okay, so there's your limit stuff. Alright, and it's, yeah. Alright, so let's do this one. Okay, so I'm going to find the intercepts. My vertical, the intercepts, asymptotes. I like my asymptotes first. So I'm going to find my vertical asymptotes by saying denominator equals 0. So add 1, x cubed equals 1, cube root, x equals 1. So I'm going to have a vertical asymptote at x equals 1. Okay, my horizontal asymptote, my top degree is 3, my bottom degree is 3, they're equal, so y equals my top leading coefficient divided by my bottom leading coefficient, so y equals 2, will be my horizontal asymptote. Okay, and let's see, we want intercepts, so to get x-intercepts, you set your numerator to 0, 2x cubed minus 3x plus 2, and you set it to 0 and you solve it, which we would have to use a PQ list and all of that stuff because it's the third degree. We can't use quadratic techniques, so we're going to cheat a little bit and use the calculator. Alright, and it looks like I've got an x-intercept at about right there. Okay, so there's my x-intercept. My y-intercept, you find h of 0, which would be 2 times 0 cubed minus 3 times 0 plus 2 over 0 cubed minus 1. That's going to be negative 2. So 0, negative 2 is where it's going to cross the y-axis. Okay, and again, then we would pick points to get a good graph, but we cheat. And we know that it's going to approach that asymptote. Looks like it makes this funny little dip looking thing here. It comes up and then down to infinity, and then you got the boomerang up here. That was a really bad drawing. Okay. End behavior asymptote. The end behavior asymptote is the horizontal or the slant asymptote. So if we describe the end behavior, the limit as x approaches negative infinity. As I approach negative infinity, if I'm tracing this, as I get closer and closer and closer, this function is getting very, very close to that red line, which is 2, which means my function is approaching 2. Okay, my limit as x approaches positive infinity, now I'm tracing this way. So if I trace this side closer and closer to infinity, this again is getting closer to that red line, which means my function is approaching 2. Okay, now if you do to your vertical asymptotes, this one right here, okay, the limit as x approaches 1 from the left, if I'm approaching 1 from the left, okay, I'm coming up to this line from the left, and close to this line to the left, the function is heading down. So I would say the function is going to negative infinity. And if I do the limit as x approaches 1 from the right, now I'm tracing it, I'm getting close to this line from the right, and that makes my function go up, which means as I take the limit, my function is going to positive infinity. Okay? So there's your limits. Alright, so how do you use a graphing calculator to find and confirm all attributes of a rational function? Well, we find the vertical asymptotes, the horizontal asymptotes, the x-intercepts, the y-intercepts, and then instead of generating a whole bunch of points, we are going to, then we use the calculator to get a complete picture. Okay, so 6 says compare these two and see if their domains are equal, if they have a vertical asymptote, and why they appear to be identical. I'm not going to do it for you because I want you to think through it, but I'll give you a hint. It has something to do with factoring that and canceling out, and it turns into a whole instead of an asymptote. You figure that out. Alright, so we are at homework, which means we are done. So, happy homeworking, and I will see you next